Good morning. The Subcommittee on Research and Technology will come to order. We're going to have a little bit of a change of order today because on our first panel, Congressman Tom Reed is in a markup in another committee that he's delayed and couldn't testify first, so we're going to go to our second panel. So I'd like to welcome everyone to today's hearing titled Building a Network for Manufacturing Innovation. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witnesses. I'll recognize myself for 5 minutes for an opening statement. I'm pleased to call to order this morning's hearing to examine the need for a manufacturing innovation network and to review H.R. 2996, the Revitalization American Manufacturing Innovation Act of 2013, authored by Representatives Tom Reed of New York and Representative Joe Kennedy of Massachusetts. I am pleased that Congressman Reed and Congressman Kennedy will be joining us later today as witnesses to discuss their proposed legislation. Nationally, manufacturing supports 17.2 million jobs with 12 million Americans, or roughly 9% of the workforce, employed directly in manufacturing. Manufacturing represents approximately 11% of the American economy and has the greatest multiplier effect of any major sector in the American economy. According to the Bureau of Economic Analysis, each dollar spent in manufacturing generates an additional $1.35 in spending. In Indiana, there are nearly 10,000 manufacturers employing more than 500,000 workers, which represents 1/6 of Indiana's workforce. Not surprisingly, my state ranks first in manufacturing employment and second in manufacturing as a gross state product. The 8th District of Indiana is home to many of these manufacturers, and I have seen the work being done firsthand at manufacturers like Berry Plastics, Toyota Motor Corporation, and Alcoa. Along with the many manufacturers in our district, universities like Vincennes University, the University of Evansville, and the University of Southern Indiana offer degrees related to advanced manufacturing and work closely with these entities to develop a talented, well-trained workforce. H.R. 2996 would establish a $600 million new program based on the President's FY13 and FY14 budget request for the National Network for Manufacturing Innovation. H.R. 2996 would establish a network for manufacturing innovation, building a public-private partnerships through centers for manufacturing innovation. Nearly half of the government spending in 2012 was spent automatically on mandatory entitlement programs. And here in Washington, D.C., we're having an ongoing discussion about reining in the spending on the mandatory programs in order to prevent budget cuts to government programs such as research and development that also may affect such proposals as 2996. I look forward to hearing from all our witnesses and their thoughts about the proposed legislation, and I thank them for joining us today. Now I recognize the ranking member, the gentleman from Illinois, Mr. Lipinski, for his opening statement.
Thank you, Mr. Chair, and thank you for holding this hearing. And I think that I want someone to count up the hearings. I believe hard to believe anyone has had more hearings than we have had in the subcommittee, but that's great because we're looking at a lot of very important issues to the country, such as this one on manufacturing. I'm looking forward to a hearing from Mr. Reed and Kennedy about their bill, and prior to that, hearing from our expert witnesses here in front of us who are going to testify as the subcommittee continues its examination of what we can do to revitalize America's manufacturing sector. The legislation we're discussing today is based in large part on the proposed National Network for Manufacturing Innovation, or NNMI. I've been a strong supporter of the NNMI concept, and I'm proud to be a co-sponsor of H.R. 2996. Although we've heard time and time again about the crucial link between economic growth and a vibrant U.S. manufacturing sector, I think these facts bear repeating. At 60% of all exports, manufacturing is the largest contributor to U.S. trade. Manufacturing employs more than 11 million Americans in jobs providing above-average pay and benefits. The sector adds approximately $1.6 trillion to our gross domestic product. According to the Bureau of Economic Analysis, manufacturing has a larger multiplier effect than any other major economic activity. $1 spent in manufacturing generates $1.35 in additional economic activity. And finally, manufacturing accounts for nearly 70% of private sector research and development. Behind all of these facts and figures is a strong link between manufacturing and innovation. And let's be honest, our nation's competitive edge is slipping. We have to take note of countries such as Korea, Japan, and Germany that have a larger share of the advanced manufacturing sector than the United States. These nations and others are investing heavily in manufacturing and innovation, and they are doing so in a much more comprehensive way than we are. It's not as if the federal government isn't doing any good work in the areas I mentioned, but if we want to create the environment that will produce the high-paying jobs of the future and help this country keep its competitive edge, then we need to do more to support and expand advanced manufacturing. The legislation we are discussing today has the potential to do just that. The manufacturing institutes created under the proposal can serve as centers of manufacturing excellence, accelerating innovation in the transition of cutting-edge manufacturing technologies and processes to the marketplace. They can also serve as a nexus for addressing our manufacturing talent shortage. I think it is important for a manufacturing workforce, from scientists and engineers to production workers and technicians, to have access to and experience with new, innovative technologies. H.R. 2996 is modeled after the successful Fraunhofer Institutes in Germany. Many experts believe Germany has been able to withstand the global financial crisis, in large part due to its focus on innovative technologies as a key driver of economic growth. The Fraunhofer Institutes are widely considered to be a central and key component of the country's high-tech strategy. Based on Germany's success, a number of countries, including Britain and France, have adapted the Fraunhofer model to improve the competitiveness of their manufacturers. And in fact, sources ranging from a recent National Research Council report to groups like the National Association of Manufacturers have called for the establishment of a similar network of public-private manufacturing centers in the United States. Simply put, made in America equals American jobs and a strong economy. Now, when our position as a global leader in science and technology is being threatened, we can't afford to lose our capacity to create the breakthrough technologies of tomorrow. Mr. Chairman, we must adopt smart policies that encourage innovation and investment in manufacturing. I believe H.R. 2996 is a smart policy. I look forward to working with you and all of my colleagues to advance legislation like this that will help keep American manufacturing strong. Thank you, Mr. Chairman. I yield back the balance of my time.
Thank you, Mr. Lipinski. I'd now like to recognize the ranking member of the full committee, Ms. Johnson, for her opening statement.
Thank you very much, Mr. Chairman. I'd like to compliment and praise my colleagues, Mr. Kennedy and Mr. Reed, for their bipartisan work to advance the legislation we are considering this morning. The purpose of H.R. 2996 is conveyed in the legislation's title, the Revitalize American Manufacturing and Innovation Act. I am supportive of this legislation and its purpose to revitalize American manufacturing because I strongly believe that if the United States is to remain competitive in the long term, we need to ensure that American companies maintain their capacity to manufacture innovative products right here at home. The key to maintaining this capacity is through strategic investments in advanced manufacturing research, development, and education. While the United States is struggling to sustain its competitive edge, other countries are focusing their full attention on manufacturing. They are implementing the policies and programs necessary to build the 21st century economies now. We simply cannot afford to stand on the sideline and watch our competitors pass us by. A vibrant manufacturing sector is just too important. That is why earlier this year I introduced the Advanced and Innovative Manufacturing Act of 2013, or the AIM Act. My legislation also brings the public and private sectors together to tackle the research needs of the industry. Additionally, the AIM Act focuses on ensuring small and medium-sized manufacturers have the tools they need to innovate. Because the decline of U.S. manufacturing is a threat to the middle-class jobs in our economy. The Democratic discussion draft of the America Competes Reauthorization Act includes a number of manufacturing-related provisions. In fact, the proposal we are considering today is a part of that discussion draft. We need our manufacturing sector to be the most sophisticated in the world, using transformative technologies and manufacturing processes. By doing this, we can maintain our global leadership. And I'm hopeful that as this committee considers the reauthorization of NSF, NIST, and DOE's Office of Science, we can come together across the aisle to include policies that will stimulate American manufacturing and American jobs. Mr. Chairman, on a daily basis, many times we hear about spending so much on Medicaid, spending so much on other aid programs. Well, Mr. Chairman, until we pass legislation of this sort, we'll be increasing those roles rather than eliminating them. I hope that this legislation can move forward. I thank you and yield back the balance of my time.
Thank you, Ms. Johnson. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. I'm now going to introduce our panel of witnesses, and then we'll hear their testimony. Our first witness is Mr. Jonathan Davis, Global Vice President of Advocacy for SEMI, the Global Industry Association serving 2,000 member companies in the nano and microelectronics manufacturing supply chains. Prior to this, Mr. Davis served as the head of the Semiconductor IC Business Unit. Mr. Davis earned a 5-year architecture degree from Kansas State University College of Architecture and Design and studied at the University of Missouri at Columbia School of Journalism. Our second witness is Dr. Richard Albrecht, Vice Chairman of the Board and Vice President for Strategy and Technology at Moog Incorporated. Dr. Albrecht began his career at Moog in 1969 as a design and development engineer. Dr. Albrecht studied at the Sibley School of Mechanical Engineering at Cornell University from 1962 to 1969, where he earned his bachelor's, master's, and doctorate degrees. Our third witness is Dr. Stephen Biller, Chief Scientist for Manufacturing Technologies at GE Global Research. He is responsible for GE's global advanced manufacturing strategy and the development of GE's smart manufacturing innovative across GE businesses. Dr. Biller received a degree in electrical engineering from the RWTH Aachen in Germany, a doctorate in industrial engineering and management science from Northwestern University, and an MBA from the University of Michigan. And our final witness is Dr. Stanley Voyeur, resident scholar at the American Enterprise Institute for Public Policy Research. His academic research focuses on political economy and applied microeconomics. Before joining AEI, Dr. Voyeur was a teaching fellow at the Harvard Kennedy School, Harvard College, and the Universitat Pompeu Fabra. He is a graduate of Utrecht University and Erasmus University Rotterdam and holds a master's in economics from the Universitat Pompeu Fabra. That's hard to say. As well as a master's and doctorate in economics from Harvard University. Welcome to all of our witnesses. As you should know, the spoken testimony is limited to 5 minutes, after which members of the committee have 5 minutes each to ask questions. Your written testimony will be introduced into the record of the hearing. I now recognize our first witness, Mr. Davis, for 5 minutes for his testimony.
Chairman Bouchon, Ranking Member Lipinski, and members of the committee, thank you for allowing me to be here to testify before you today on the need to strengthen advanced manufacturing in the United States through public-private partnerships like the ones authorized in H.R. 2996, the Revitalize American Manufacturing and Innovation Act. SEMI is a global industry association with about 500 U.S. member companies that serve the semiconductor manufacturing supply chain. Semiconductors are small integrated circuits, or ICs, more commonly known as computer chips. But today these chips power far more than computers. They are the essential enabling technology for all electronics and electronic systems: computers, cell phones, tablets, TVs, automobiles, medical devices, and components and systems for national defense and security. SEMI represents a manufacturing supply chain that is heavily dependent on innovation and commercialization to perpetuate an incredibly advanced pace of technological development. On average, SEMI North American member companies reinvest 10 to 15% of their annual revenues into research and development each and every year. The cost to commercialize technology continues to increase as we compete with global competitors supported by foreign government investment. Governments around the world understand the strategic value of complete manufacturing supply chains. Many are supporting efforts to assist homegrown manufacturers to compete with U.S. companies while also providing powerful incentives for U.S. manufacturers to move offshore. In the case of semiconductor manufacturing equipment, we see intense efforts by foreign governments to commercialize next-generation technology outside of the United States. In Europe, they've launched the 10-100-20 strategy that will supply 10 billion euros from the EU to leverage large investments by industry with a goal of 20% market share. In China, the 12th five-year plan from 2011 to 2015 from the central government calls for $600 billion for 7 priority technology areas, 2 of which include semiconductor-related equipment. Taiwan and Korea also have robust funding support in efforts to strengthen their local supply chains for their important national industries. This localization effort often results in direct pressure on U.S. technology providers to relocate to their regions. Often for both financial or customer relations reasons, the pressure to relocate overseas is formidable. We understand that the U.S. faces its own budgetary fiscal challenges related to discretionary and non-discretionary funding. Mandatory funding continues to grow while non-discretionary funding becomes smaller, and that model simply isn't sustainable. It's our hope that Congress will find the correct balance between discretionary and non-discretionary programs so that worthy policy objectives such as H.R. 2996 can be debated and, we hope, implemented. We believe that 2996, the Revitalize American Manufacturing and Innovation Acts, provides the needed leadership by the United States government to compete with foreign governments and to strengthen and grow a strategically important manufacturing industry. This legislation provides public-private partnership model that we believe will strengthen the supply chains of numerous strategic manufacturing industries. The legislation doesn't help one company or one university. It enables an entire vertical supply chain for specific manufacturing industries. We believe that's the proper role for the federal government to take, assist an entire industry with everyone, including academia, state and local governments, and industry, putting skin in the game. 2996 authorizes the creation of centers for manufacturing innovation. Each center will focus on a specific technology for the commercialization of manufactured goods. Such a model allows for pre-competitive research or pilot-scale manufacturing product development. As I said earlier, semi-member companies' cost to commercialize the next generation of technology into manufactured product is extremely expensive. Having a shared manufacturing pilot line for all companies, including large and small, that are part of the supply chain, saves resources for everyone. It's especially important for small and medium suppliers who cannot afford the high cost to commercialize technology. The legislation is technology neutral. The government cannot require specific technologies. Rather, they will be competed through a merit-based solicitation process. One of the technologies our member companies produce are light-emitting diodes, and I see mine is red now. So I will refer you to my written testimony and be happy to answer questions later.
Thank you, Mr. Davis. I'll now recognize our next witness, Dr. Albrecht, for his testimony. 5 minutes.
Thank you very much for this opportunity to testify. Well, let me start by giving a little background on Moog. We're headquartered in Buffalo, New York. We've been in business for about 60 years. We actually spin out of Cornell University to begin with. Our primary products and technologies relate to precision motion control. We supply flight controls for aircraft. We have all the flight controls on the F-35, have the same position with Boeing on the 787 and with Airbus. This is the first time Airbus has ever gone outside Europe for that sort of control system. And just recently we won the same kind of a program at Embraer in Brazil. We're a global company, about $2.5 billion in sales, 13,000 employees. We are a manufacturing company. We've had a history of 60 years of being on the leading edge of the technology, but what enables that is to be a leading edge manufacturer. It's not just a matter of being able to design things, you got to be able to make things. And so with our global perspective, I travel all over the world. We have locations in 30 countries around the world, 15 manufacturing locations around the world, 7 locations in the U.S., and so I'm very aware of the competitive nature of international manufacturing, and a lot of what we sell overseas, we make overseas, but we also export a lot from our facilities here in the U.S. I'm in full agreement with the premise outlined in the Dear Colleague letter. Manufacturing is very important in the U.S. economy, and it also is highly dependent upon the skilled technicians and machinists and electronic technicians that put our products together every day. Currently, we're facing a significant increase in our need for training. We had a great growth period in the 1970s and 80s. A lot of these people are retiring over the next 10 years. So we have significant need at this point in time for improved training. I believe the question we should be asking today is not, do we need more training, but how to more effectively provide training. This act is about productivity and about innovation. And I would suggest to think about how you can be more productive and innovative in training. Recently, in the last 5 or 6 years or so, there have been what are called massive open online courses have been developed. There's 100 universities that have joined consortia such as Udacity and XED is the other one. And they're redoing the model for providing education. And it seems to me that you could take that model and use that for providing a lot of the basic training that you need for manufacturing technicians of all kinds, machinists, electronic technicians, software programmers. It can be done online. That's the whole premise of that sort of training. The reason for doing it is that you can get the very best lecturers to put the courses together and then provide them asynchronously to people all over the country. So you've got an ability to be able to deliver wherever it is. We have some of our facilities in Murphy, North Carolina. There are no training facilities in Murphy, North Carolina. This would enable us to be able to provide courses to these sort of people all over. The other is that it's asynchronous. So people can do it on their time. You don't have to show up at 7 o'clock on Tuesday and Thursday evening and drive 100 miles to go to the course. So to me, the federal government could play a very key role in seeding that sort of capability. Work with people like Coursera and XED that have put these programs together. They have the technology already worked out to provide the courses. What's needed is somebody to pull that together and provide the seed funding. There's also, it seems to me, a number of natural partners for all of that. There are the companies who manufacture the equipment. They already have training programs in place, but they're all in-place programs. You have to travel to wherever their training centers are. Very expensive to do that. The other there are part of what's mentioned in the material for the Act is talking about supply chain management. There are 2 associations of people, of supply chain managers. They already have training and certificate programs. You could work with them and provide their kind of training online all over the country. So it seems to me when you think about innovation, you want to think about how is it we can provide more training at a much lower cost. The universities that have gone into this already have seen that the cost per student goes down by an order of magnitude. It's down less than 10% of what it costs to do it in place. And the other countries that I travel to aren't even thinking about this at this point in time, even at the university level. So if the U.S. wanted to gain a significant advantage in training for manufacturing, this would be one way of doing it. Use the online capabilities that are already there. In summary, I think the government could very effectively take that sort of a role and provide the necessary risk capital, is the way I think of it, to be able to get this sort of thing going. It's not going to happen unless somebody like that steps in and does it. Industry will support it once it's there, but you have to have somebody who takes it and pulls it together. And as they say, there's natural partners. You don't have to start from ground zero. So thank you very much.
Thank you, Dr. Albrecht. I recognize now Dr. Biller for 5 minutes for his testimony.
Chairman Booksham, Ranking Member Lipinski, members of the committee, it's a privilege to share with you today GE's thoughts on the creation of the NNMI program and the establishment of Centers of Manufacturing Innovation, or CMIs. GE Global Research was America's first industrial research lab, established in 1900. For more than 100 years, it has been the cornerstone of innovation for GE and a proud contributor to U.S.-led manufacturing revolution that helped shape and define the 20th century. Today, we would like to share GE's thoughts on launching an NNMI and the critical role such an initiative can play in helping American companies be leaders in the next manufacturing revolution that's rapidly defining the 21st century. Innovation has always been one of our nation's greatest assets, but if the U.S. is going to be a leader in manufacturing moving forward, the country needs to embrace new trends that are driving our ability to compete.
Dr. Biller, could you pull the microphone closer?
Is this better?
That's
I'm
much
sorry.
better.
Okay. To become more competitively globally, government support for innovation has to become more targeted, involve more partners, and committed to a longer time horizons that are closer to commercialization. Other developed high-wage countries such as Germany and Japan have long taken such an approach and found much success considering their levels of manufacturing employment. Similarly, the launch of the NNMI would embrace this innovation model and significantly improve the competitiveness of U.S. manufacturing. The success of the NNMI will depend on having a healthy ecosystem of centers of manufacturing innovations, or the CMIs, with participants from academia, government, and industry. We believe that it is paramount to U.S. manufacturing competitiveness that the CMIs help small and medium enterprises, the SMEs, introduce novel manufacturing technology into the U.S. manufacturing supply chain more rapidly. To provide these SMEs with the best possible framework to succeed, we recommend adapting a Sematech-like collaboration model that provides broad access to state-of-the-art equipment, draws leadership from CMIs from industry, and leverages CMIs as training ground to develop an advanced manufacturing workforce. We believe the NNMI can provide the broad framework that strengthens the U.S. industrial-based position as a global manufacturing leader. Last year, GE was very pleased when the first Innovation Institute was established under the NNMI in additive manufacturing, or NAMI, in Youngstown, Ohio, and proud to be an industry partner. Already, NAMI is beginning to show how big companies like GE can connect and work effectively with small and medium companies to push new advancements. In the same way that CMIs should draw upon the unique skills of academia, government, and industry, it is equally important for each of the CMIs governing board to draw its membership from academia, government, and industry. When it comes to day-to-day operations, however, the leaders for each institute and the number of their staff should be recruited from private industry and have demonstrated experience in the insertion of advanced manufacturing technology into production. We believe that is really the key. This will ensure that industry sees the benefit of engagement with CMIs and participants in these institutes on a long-term basis. Many large companies like GE have continued to use apprenticeship programs to build the skilled workforce of tomorrow. The skills gap, however, is not limited to producing a production workforce. The proportion of science and engineering workforce older than 50 has risen significantly in recent years as well. We must also place emphasis on replenishing the advanced manufacturing researchers that will be necessary to develop tomorrow's technology breakthroughs. The NNMI is really an ideal place to do that. Regarding the design of these CMIs for broad impact, GE would like to make the following recommendations. Each Center for Manufacturing Innovation should focus its effort addressing the fundamental technical barriers that prevent manufacturers from broadly adopting specific technologies. To accomplish this, each CMI should adopt an inclusive Sematech-like approach that includes participants from each part of the manufacturing supply chain. The equipment within each of these CMIs should be made available to all companies so they can conduct manufacturing trials to reduce implementation risks and improve the productivity and competitiveness of their manufacturing operations, very much like the Fraunhofer Institutes in Germany. At the same time, companies that provide advanced technology equipment to the CMI should be allowed to count these in-kind contributions toward membership or participation fees. This will ensure that the CMIs will always have access to state-of-the-art equipment. The advisory boards that provide direction to the CMI should be comprised of individuals from industry, government, academia, but the leadership teams should be recruited from industry and should have experience in the insertion of advanced manufacturing technology. Additionally, the NMNIs should create a mechanism for collaboration, technology transfer, and best practice sharing. Finally, working with community college and universities, CMI should provide internship to train future advanced manufacturing workforce. Furthermore, mechanisms should be created to allow private sector employees to collaborate the CMIs for long-term assignments. The NNMI represent really a significant opportunity for the United States to restore its manufacturing prowess and improve its competitiveness. GE is really committed to creating an industrial manufacturing ecosystem by working with other organizations to form these CMIs. Thank you, and I look forward for your questions.
Thank you, Dr. Biller. I now recognize Dr. Voyeur for 5 minutes for his testimony. Welcome.
Thank you. Mr. Chairman, Mr. Ranking Member, I'd like to thank you for the opportunity to testify today before the committee. I'm here to discuss the need for a manufacturing innovation network as proposed in H.R. 2996. H.R. 2996 proposes to appropriate $600 million for establishing a network for manufacturing innovation consisting of centers for manufacturing innovation. These centers are meant to address challenges in advanced manufacturing to retain or expand industrial production and jobs in the United States. They must do so in areas determined by the Secretary of Commerce to be of importance in attaining these goals, and they must feature representatives from multiple entities from a broad range of categories. The Secretary of Commerce's decision as to which centers are worthy of federal funding will be based, besides these overall goals, on criteria including the involvement of small and medium-sized manufacturing firms, as well as on how the Center for Manufacturing Innovation will strengthen and leverage the assets of a region. Now, according to the Bureau of Labor Statistics, the manufacturing sector employs some 12 million workers in the U.S., down from almost 20 million in the late 1970s. That is about 500,000 more than at the end of 2009, but still about 2 million fewer than before the start of the Great Recession. These figures do not suggest what is commonly referred to as a true renaissance of U.S. manufacturing, but a look at manufacturers' sales figures provides much more of an underpinning for such a view of U.S. manufacturing. According to the Census Bureau, manufacturing sales are indeed back where they were at their previous peak. After falling by about 25% during the recession, they had rebounded by July of this year. What this suggests, of course, that most of the recent resurgence of manufacturing in the United States has been highly capital intensive. That is, output is increasing without much new hiring. This has been true for decades, is mostly a product of technological progress, and does not appear to be a trend that is about to reverse. It is also certainly not a phenomenon that's unique to the United States. Even Germany, touted for its positive trade balance in advanced manufacturing products in H.R. 2996, has seen manufacturing employment as a share of total employment plummet over the past 40 years. These broad, long-term developments, driven by technological change more than domestic public policy, are important to consider when analyzing the state of manufacturing today. It seems unlikely manufacturing will regain its old central role in the labor market in our modern economy, and striving to reverse the trends highlighted before is likely to be costly, yet ultimately fruitless. Now, new spending initiatives like the Manufacturing Innovation Network proposed here look even less attractive if we also consider the state of the federal government's finances. Over the past 40 years, mandatory spending, particularly on entitlement programs such as Social Security and Medicare, has escalated rapidly. Less than 20% of the federal budget now goes toward programs other than Social Security, Medicare, Medicaid, CHIP, other safety net programs, defense, and interest payments. And almost half of that, half of the remaining 20%, pays for benefits for federal retirees and veterans. This development puts immense pressure on discretionary spending programs, some of which are quite crucial to the nation's future. Instead of allocating funds to new manufacturing innovation initiatives, I prefer that current spending on scientific and medical research be maintained and some of the more unfortunate sequestration cuts in those areas be reversed. More importantly, to preserve such important programs, Congress needs to commit to serious entitlement reform in order to keep entitlement spending from further crowding out all other spending. At the same time, setting the stage for enduring American competitiveness is certainly within the realm of the possible. By removing uncertainty about the country's fiscal policies, by providing tax and regulatory relief to both manufacturing and non-manufacturing firms, by training workers to be able to function in today's globalized economy, and by benefiting from the domestic oil and gas industry's newfound health, the U.S. can continue to be home to extraordinarily successful, innovative firms in manufacturing and elsewhere. In sum, I believe that there's a variety of ways in which to address or at least alleviate some of the problems often attributed to the decline of manufacturing in the United States. None of these are cure-alls, but some of them, though possibly politically difficult, are more genuinely beneficial than others, including corporate tax reform and entitlement reform. Thank you.
Thank you, Dr. Voyeur, for that testimony. I'd like to thank all the witnesses for their testimony and reminding members that the committee rules limit questioning for 5 minutes. The chair at this point will open the round of question, and I recognize myself for 5 minutes. Dr. Albrecht, I'm interested since your company is so global, if you had 2 or 3 things that are really potentially disadvantaging the United States versus the rest of the world when it comes to manufacturing, what would those be?
Regulations would be the one that would head my list.
And what direction do you think the rest of the world's going when it comes to these type of things like regulation, taxation, and everything? And let me just give you an example. There's an business in my district, a large company, that when I talked to the CEO and he told me what his offer was to move his company to a foreign country, it almost seemed like an offer you couldn't refuse, except for the fact that American manufacturers want to stay in America and they want to employ U.S. citizens. But on the face of it, it seemed like a pretty difficult offer to refuse, although they did. What are the few things do you think that America that we should be doing that will make us be able to compete with offers like that from around the world? I mean, just in general, other than regulation, as you see it.
Well, the whole topic of the day is on innovation in manufacturing, and as I focused on was the training aspect of the whole thing. Our assets walk out the door every night, and you need to maintain the capability of the people in the organization, from the design engineers down to the people that are putting the product together on a daily basis. And in terms of productivity, our American workforce that we have in Buffalo is the best that we have anywhere in the world. At the same time, the Buffalo economy is not doing all of that well. We put an ad in the paper or online for somebody, we get 100 applicants for one spot. And so I think our experience that way is not typical for a lot of American manufacturers. We are able to get the people and retain the people. We have less than 1% turnover in the company. But as I say, we have people retiring and now trying to find other younger people to come in and replace them. We're having to do a lot more training. We have had apprentice programs that we run with the community college. We've also become a much more global company. If you go back 20 years, 90% of our manufacturing was done in Buffalo, New York. And today we're down to maybe 25% because we made acquisitions. We put facilities in other places in the U.S., and we're finding the training capabilities in those places are not as good. The flip side of that is, you're talking earlier about the Fraunhofer Institutes. I spent 3 years living in Stuttgart and worked with the Fraunhofer Institutes there. That provides a great advantage. One of the real advantages that Germany has is not just that kind of a capability, but the training programs that they have that start in what you think of as 9th grade in the U.S. People come out, we can hire people at 19 and put them in front of a $500,000 machine tool and they know what to do with it. And we can't do that here in the U.S. That's the thing we need to improve on, is the skills to be able to actually execute. We've got great design engineers, great capability, but the question is, how well do you execute that? I would also suggest that one of the things you ought to think about with this is they say we do about $2.5 billion. $700 million of that is sales that ultimately end up to the U.S. government. So our productivity is of great interest to you as well in terms of how much do you get for your defense spending dollars. And so I would think that that would be another place that you ought to be thinking about it, is how is it you could link with other people who are customers in the government for the products we end up producing.
Thank you. And I also serve on the Educational Workforce Committee, which this is a challenge that that committee is working on, as trying to figure out K through 12 education, and where, like you pointed out, where we can make some adjustments that when people finish high school, that they already have a significant amount of skill, if that's their area that they want to pursue, and have those options available to them at the high school level, and come out with upfront better training. And I think we're going to start doing a better job with that. We've gotten a little bit behind, but I think we're going to catch up. So that definitely is important. I'm going to all witnesses. I'll start with Mr. Davis. We've held a number of hearings in the subcommittee, and we're considering legislation to reauthorize funding for basic research at NSF, NIST, and the DOE Office of Science. As you know, we're facing difficult budget times, and what recommendations would you have for policymakers in prioritizing federal spending on advanced manufacturing programs?
Thank you, Congressman. Clearly, I think in the context of today's discussion, our industry views the research and development that is oriented towards commercialization, how we take innovation and make sure that those innovations propel economic growth, jobs, and prosperity in the United States.
Dr. Voyeur, you have any comments on that? And then I'm going to be out of time. Am I out of time? I'm out of time. Excuse me. I now yield to the ranking member, Mr. Lipinski, for his questioning. Thank you.
Thank you. I want to thank all of our witnesses for their testimony, and in pointing out that this is this bill really proposes that this is going to be a public-private partnership led by industry, and I think that that's very important, and that Mr. Davis had brought up that this will be assist in an entire industry. And I think those are important things that to understand about this bill. And Dr. Albrecht certainly couldn't agree with you more on the need to do better with training. And I'm glad to hear in Buffalo that the supply of workers and qualified, ready workers is there. But I certainly hear from manufacturers in Chicago that that's not necessarily the case. I think we need to do more on that. But I wanted to ask Dr. Biller, as proposed in this legislation, the main purpose of the Centers for Manufacturing is to close the gap between R&D activities and deployment of technological innovation in domestic production of goods. It's been one of my biggest issues for me is to do what we can at the federal level to help to close that gap. We have great R&D that goes on in this country, and unfortunately, so much of it does not get deployed into innovation, and some of it that does is not done here. So in your testimony, you mentioned the federal government support has to involve more partners and be committed to longer time horizons. You also indicate that research collaborations need to continue to later stages of R&D closer to commercialization. So I want to ask, does the legislation address the needs you've identified in your testimony? And why is it important that research supported by the centers get to the production level or later stages of R&D?
It's really all about getting over that valley of death we have been talking about for technology readiness level 4 to 7, which is really what the Fraunhofer Institutes and the Sematech model essentially addressed. So it's important for companies like General Electric that we have access to that. But I think it's even more important that we create an ecosystem of small, medium enterprises that have access to that kind of technology, because they have neither the skills nor the money to develop technology through that valley of death. And just as we have seen now in the additive manufacturing space, where the creation of an ecosystem allows us to draw upon an innovation capability from a much broader supply base, we need to think about how we're going to create that ecosystem of a much broader supply base with EMEs in traditional manufacturing, which is probably 99% of current manufacturing, and additive being maybe 1 or less. So to us, to stay globally competitive, in particular in the U.S., it's very, very important that we get our small, medium enterprises through that valley of death and give them access to advanced manufacturing technologies. And I think that's where the NNMIs can play a key role in accomplishing that. So that's why we are so supportive of this model. And again, in Germany and Japan, you have SMEs being so successful in being world leaders because they have a support like the Fraunhofers or the Japanese equivalent.
Hey, and sort of getting back to the public-private partnerships, why are these so, and you've talked about a few things, are there other things you could talk about why these are so attractive to industry?
If we think about, for example, the suggested DMDI Institute on Digital Manufacturing Innovation, there the SMEs need to learn simulation capabilities to design product in virtual, launch their factories in a virtual environment, thereby increasing innovation, decreasing cost. They have to integrate with the large companies in a digital space. They currently don't have the engineers trained to do that. They currently don't have the software available to them to do that. We need to think of these CMIs as a commons, essentially, where we're going to train our SMEs as well as develop technology and give them access to that so that they stay globally competitive. For us, it's always, the best thing is make where you sell. Thereby you are the closest to your customer, your product engineers are together with your manufacturing engineers, and we need to think of manufacturing as a requirement for product innovation. That's why we think it's so important.
And as manufacturing leaves this country, that's the great fear that innovation will also leave the country as the people who are doing the innovation are moved over, or it's all done where the manufacturing is done outside of the country. So thank you. I yield back.
Thank you. I now recognize Mr. Schweikert for 5 minutes for his line of questioning.
Thank you, Mr. Chairman. I want to sort of back up and maybe even move slightly more conceptually. Gentlemen, if you were to lay out in front of me and say, here's where we're finding innovation, creativity, sort of breakthrough concepts as much as technology, and I don't mean it geographically, I mean it organizationally. Are you finding it coming out of universities? Are you finding it coming out of small manufacturers? Are you finding it when a half a dozen engineers from Intel go off and start their own business? Where is that ecosystem of the sort of the cutting edge ideas? Where's it coming from? And Mr. Davis, start there.
So if I could say all of the above, and I think that's one of the attractive elements of this legislation, is it tries to leverage the synergies between private enterprise, universities, state and federal governments, small and medium-sized enterprises.
Well, but back to the very precise in the question. Where do you see the innovation actually happening?
So innovation and invention are two different things in my mind. I think invention happens in fundamental research in universities where basic breakthroughs occur. Innovation becomes the application of
the adoption of.
Yeah, the adoption and application of those inventions in commercial ways. I think from an industry association perspective, we see innovation happening with companies who take ideas to market.
Doctor?
For us, it's primarily our design engineers. Our fundamental business model is to get very close to our customers and find out what their problem is. This is the classic Clayton Christensen, find out what your customer's problem is and go solve it. And it's that interface with our customers and that dialogue that happens between our design engineers for our customers and our engineers. That's where the innovation happens. When we were doing the 787 program, we had 25 of our engineers working in Boeing's Seattle facility for about 4 years to design our flight controls right into the aircraft. There was a tremendous amount of innovation that came out of that. The experience that our people get doing that is what's led us to do the next generation for other aircraft then.
Okay, so your smart people went on site with your customer.
Exactly, and that's where we see the most sources of the innovation is working with your end customer and understanding what their problem is and having your people work with them. It's the same with manufacturing. It's getting our manufacturing people to work with, sometimes it's universities, sometimes it's the equipment manufacturers, talking to the equipment manufacturer about your machine's doing this great. However, if you did this with it, and again, it's the same sort of thing upstream.
But that's the translation of the knowledge that's been gained. I'm sort of trying to understand where that ideas are germinating.
It's the same kind of conversation.
Okay, Dr. Biller?
I agree wholeheartedly with Dr. Albrecht. It happens in the factories when our researchers go to those factories, try to figure out where are the pain points, what are the problems for us, our factories, other customers, and then conversely, when we go into our supply chain, we help our SMEs and our business partners in the same way. We're trying to find out what the problem is, go after the problem. Innovation really happens for manufacturing on the plant floor with smart people, including academics, including people from government labs, including people from industrial research labs.
Okay, Doctor? This is easy. I can just sort of go doctor.
Exactly. I think I would agree with the all of the above answers. I think all of the previous speakers have given, and I think that's what makes it hard to justify the federal government giving preference to certain processes, certain groups, certain places over others, and to what is admittedly a large part of the economy, but still one sector, one industry over others.
Can you elaborate on that, because it's touching on one of my concerns is often when a piece of legislation like this that's very well meaning does, because of the financial incentives and mechanics built into that, do you start to silo where innovation actually starts to be developed because the financial incentives are there? So, Doctor, please continue there.
I mean, I mean, it seems clear that a bill like this subsidizes innovation in manufacturing over all other innovation in R&D. I mean, that may be something you want to do for some reason, but it's certainly true that there's an element of prioritization there.
Okay. Yeah. And with that, Mr. Chairman, I'm out of time. Thank you.
Thank you. I now recognize Dr. Barra.
Great. Thank you, Mr. Chairman, and I want to thank my colleague, Mr. Kennedy, for bringing this important piece of legislation and resolution to the forefront. It's incredibly timely that we're talking about how we revive a manufacturing sector and how we create jobs. I had a town hall with my constituents back in Sacramento County last night, a telephone town hall, and in that I heard from a number of folks that are consistently looking for jobs. I heard from one young veteran who returned. All she wants is to find a job. She's not asking for unemployment benefits or anything. She just wants to find a job. I also heard from a desperate couple that's been out of work for 2 years, and they are incredibly worried about unemployment benefits being cut off, but they're not asking for an extension. They need that extension, but they want a job. They've been looking for jobs. Now, Dr. Albrecht, you touched on part of our challenge, the skills mismatch. There are plenty of jobs out there, but our workforce, our graduates are not trained to meet those jobs. So we do have to double the effort to make sure we're addressing that skills mismatch. Another challenge is, maybe Mr. Davis touched on this, or all of you have touched on it, is inconsistent federal policy. I mean, we've not defined, what our goal is, how we're going to make those investments, what kind of a regulatory framework we're going to do, so we can create those jobs, so we can make those investments, so our kids, our graduates are able to fill those needs. In addition, we have seen dramatic reductions on our investment in R&D, and that creates another challenge for us. And then Mr. Lipinski touched on this issue of technology transfer, how we quickly get these ideas out of our academic institutions and out of R&D into industry, so we can commoditize them and grow industries. That said, we do have some assets and some natural advantages. I think, Dr. Voyeur, you touched on this energy renaissance that is coming. That will make our manufacturing base much more competitive. Dr. Biller, you touched on, I think that the term you used was make it where you sell. And, as I've been talking to some international multinationals, they are considering locating their manufacturing sector here in the United States because, the advantages that they have in lower costs of labor, we're about to potentially outweigh those advantages given they're selling to our market. If they build it here, they don't have the cost of transport, and we have much lower energy costs, plus we do have the rule of law and so forth here. So there are some advantages there. We're still the most innovative economy. I haven't asked a question yet. But on that sector of investment in R&D and on technology transfer, coming out of an academic background myself, and any of you can answer this question, what can we do to allow industry to partner much more closely with our academic institutions to make it easier to take those ideas to market as quickly as possible? Maybe Dr. Albrecht.
So, one of my other involvements, I'm a trustee at Cornell. I've been a trustee there for about 25 years, and one of my primary interests there has been technology transfer. And I've looked at models elsewhere around. Some of my other trustee colleagues have looked at models elsewhere around the country. There was an experiment that was run in the California university system about 10 years ago. Berkeley lives in the same neighborhood as Stanford. Stanford had a tremendous amount of industry-sponsored research. Berkeley had relatively little. And it all had to do with licensing. And what Berkeley did was to run an experiment and allow the researchers to do a royalty-free, non-exclusive licenses. And as a result of that, in a relatively short time period, Berkeley went from under $10 million to over $100 million a year in industry-sponsored research. And it seems to me that's the same sort of model. There's places where that doesn't work. If you think about medical research for drugs, a drug company is going to want to have an exclusive license. Otherwise, they aren't going to put $1 billion into developing the drug. But for a lot of other things, what they found is they put together industry consortia. We are currently partnering with about 6 universities that have industry-sponsored consortia. And a lot of those, it's royalty-free, non-exclusive licenses. It's a pre-competitive sort of research that ends up going on. And if you look at the research that the federal government sponsors coming out of the NSF or NIH or whatever, it seems to me that more of that ought to be done with royalty-free, non-exclusive licenses. What happens is researchers get together, the engineers are talking to each other. That's great. They can see the problem, they get it defined, and then they spend 1.5 years with the attorneys trying to work out a contract. This is nuts.
Right.
So do it royalty-free, non-exclusive, wherever possible. And it seems to me you could roll that into the legislation for NSF and NIH to say we want royalty-free, non-exclusive licenses. We want the scientists and engineers talking to each other, not the attorneys.
Great. Sounds great.
I'd agree with that, Dr. Albrecht.
Okay.
I now recognize Mr. Collins for his questioning.
Thank you, Mr. Chairman and Dr. Albrecht. Very good to see you again today. Moog is in my district, if you will, in East Aurora, but also they have their rocket facility up in Niagara Falls, which is also in my district. So I'd like to think at some point in time we may have more rocket scientists in the 27th Congressional District than any other in the country. And I've toured your facility. So here's my question, and I'm involved in manufacturing and in high-tech businesses. In many cases, it's the IP that makes you who you are. So Moog, a multi-billion-dollar corporation, does R&D all the time. You protect what you do with IP. That's what differentiates you, whether it's rocket engines or a new fuel source or whatever. And now we're talking about something like the antithesis to that you're going to sit down in an industry group, so this isn't going to be a Moog facility, and in that jointly develop technology where you don't have a competitive edge any longer. And I very much support this. I'm co-sponsoring this legislation, but the naysayers might say, help me through that loop of what you do now. You protect your IP at all costs, and now you're going to go try to leapfrog somewhere, and you don't have any IP. Help us through that a little bit.
To me, it's a question of, you talked about technology readiness level. When you're down at the technology 1 and 2, 3 sort of level, that's pre-competitive kind of stuff most of the time. And while you can generate some IP coming out of that, what's really important is the intellectual engagement of the scientists and the engineers at that point in time to see what's possible. And with a lot of the innovation happens today, it's not just in one field. Where we're innovating, where usually people are involved with 5 or 6 or 7 different disciplines. And the question is how you bring them together and provide a way of people can openly exchange their ideas.
Can you give like an example, like something that somebody can grab hold of and say, okay, now I got it? You're a little bit conceptual there.
Okay. Aircraft flight controls. It's the computer. But it takes people who understand the software architecture, the digital programming for all of that, how it's going to function in the aircraft. You need to have the aerodynamicists involved. You have to have the structural engineers involved. They all need to come together and be able to say, here's what the fundamental problem is. And then the people who have the specific technologies in digital hardware and digital software and systems engineering can go create a new product. And that's where the IP is created. So we have conversations with all sorts of people in those other disciplines on a pre-competitive. We're not telling them where we want to head with it, but ultimately there's ideas that come out of that. We have this kind of relationship with MIT right now. It's all pre-competitive sort of things, and we're taking those ideas and learning how to implement them. To me, it's the intellectual engagement that really drives all of that. And so with this sort of legislation, what you'd like to do in these centers is to provide that sort of independent zone where people can trade ideas and talk about things before you create IP that you consider is going to be proprietary.
So one follow-up question, since this is at max 7 years of funding, 50-50 federal government and either industry or states, and then the money's gone. And from what I'm hearing, this isn't going to be a facility that's going to be making things, having sales, making profits, covering their own costs. So it's a cash burn operation at technology 1, 2, 3. So what happens at the end? Does it go out of existence? Since it's not generating income and the money's gone, what happens after 7 years? Anybody want to?
I'll take a shot at trying to answer both those questions. You'd asked for an example of how companies might want to participate and preserve their IP. In my industry, a state-of-the-art high-volume manufacturing facility for integrated circuits can cost $5 or $6 billion or more because of the high capital equipment cost. So if you're a small or medium-sized enterprise that's trying to develop a new process or introduce a new material or test a kind of component, it's very difficult to engage. The cost of entry is so high that it's very difficult. But a shared facility would enable multiple entities to use that facility to develop processes that could then be commercialized, differentiated, and have IP associated with it. So the pre-competitive sharing of facilities is a great asset.
So in that situation, because it's shared, could you envision that, after the 7-year time frame, industry would say they're almost like a trade association? We're going to assess a certain amount of dues to keep this going after year 7, it's working great. We see the value of it. Is that
absolutely, Congressman. I think that is one example of a sustaining model that could very well work, where an established facility then becomes essentially rented out for people that want to test processes.
I can see that. Well, my time's expired. Thank you very much.
You're welcome. In fact, in my district, there's a battery innovation center outside of Creighton Naval Surface Warfare Center in Westgate, which is doing exactly what you're talking about, where multiple people from different areas are talking about trying to innovate on the next generation of energy storage, so to speak, and batteries, and I think it's going to be successful. With that, I recognize Ms. Esty for 5 minutes.
Thank you, Mr. Chairman. I want to thank you for holding this hearing, and to my colleagues, Mr. Kennedy and Mr. Reed, for introducing this legislation, which I'm looking forward to being a co-sponsor of. I'm from Connecticut, one of the homes of manufacturing, and these issues are of critical importance. I have companies such as Click Bond and Industrial Heater Corporation who are engaged in this effort. These are small manufacturing companies, frequently family-owned, who have held on through the recession by investing their family money to keep going. So this issue about workforce development is critically important. You've touched on and sort of referred to the importance on co-location, whether it's for innovation for small companies, but also being near your customer, which seems to me is a very important issue of why, if we are going to get the benefit of innovation in manufacturing, it needs to be done in the United States. That has important elements that are not captured by flying our engineers to the plants in China, because I've heard that from companies, and why, in part, not just the energy dynamic changing, but also the importance of having that close innovation happening right there on the plant floor. So Dr. Biller, I'd like you, if you could expand a little bit more on the apprenticeship programs. I've introduced a piece of legislation, the First Step Act, to try to support apprenticeship and training programs, that critical piece between not quite ready workforce and the workforce I know we need on the plant floor, that I hear from manufacturers. They have openings right now, even with a high unemployment rate in Connecticut. So can you talk about how these apprenticeship programs are working and what we could do at the federal level to help scale those up and disseminate those?
Yeah, so GE has partnered with about 190 companies to establish the Get Skills to Work program, basically trying to get about 100,000 veterans into the workforce. And there we're working with community colleges and trying to define the skills we need within our, that applies to our GE Energy business, it applies to our business in Massachusetts on aviation. We have to define those skills specifically for these people that they can use them within the factories. If we want to scale this, and I think I read your legislation, I think it's a very good idea. We want to make sure that we get certification that is truly certification. So if I look at a piece of paper that said I'm certified in XYZ, I know what that means. And so it appears to me that a national institute could certify that and thereby giving employers the assurance that a person who has such a certificate can really do a certain job. So I think that would be the way to scale it, provide community colleges with a level of certification that they then implement.
Thank you, because in part we've been approaching this, as you probably know, in Connecticut, looking at veterans as well, trying to get certification on the military side that translates to civilian,
yes,
and nationalized certification that allows transporting those skills from company to company and around the country. And would love to follow up with any of you on that point, because I do think that's a critical missing component that in our federal system, if you compare with, say, Germany or other countries that are nationalized, that has hampered us in our mobility, in our ability to make sure our community colleges and other training facilities have, if it's welding level 1, everyone knows exactly what that means. So you as an employer know what that means. You know where your employee is starting, because I think this is a critical component. Are there other pieces? It's something I'd like some of you to mention. We had an earlier hearing this year where we talked about the basic importance of R&D and, frankly, a consistent funding stream, and really looking at these innovation corridors in Silicon Valley and 128 in Boston, which were really fueled by the Department of Defense, which had very large sums of money for a very long period of time that allowed the sort of free-flowing R&D from which other things could spin out. But also had specific tasks assigned. And I know we're trying to do this around batteries right now, around energy storage. If any of you would like to comment on the importance of that sort of consistency of funding streams on the basic level, but then task-specific to try to go from there.
Yeah, I think it's really critical that we look at consistent funding, starting and stopping, waste at least a year every time you do it. And so on a 5-year program, it wastes 20% of the U.S. taxpayers' money, if that's how you want to do it. So consistency is really critical. I want to come back to the previous question of Mr. Collins, who talked about how do we sustain this. I have been a member of a Center of Intelligent Maintenance for about 13 years, where we started with very little government funding, and over time we recruited many, many members, I think 50 or 60 companies, each putting in $40,000 a year. And that became a very, so the government funding was maybe 1 or 2% of the total funding, and it was, again, a pre-competitive situation. We developed algorithms for maintenance, for machines and for vehicles, and then we took that inside the companies and implemented that. It's the implementation in this case where really the competitiveness starts, not in the development of the actual algorithms in TRL 1 to 3.
Thank you very much.
Now recognize Mr. Holkren for his line of questioning.
Thank you, Mr. Chairman. Thank you all for being here. This is a very important conversation and discussion that we need to be having, really talking about competitiveness for the United States, specifically in manufacturing and especially in high-tech manufacturing. And we need to do everything we can here in Congress to be working with you, to be helping with that. So I know in my home state, Illinois, we've got statistics say 578,200 manufacturing jobs, and 1.8 million jobs are tied in directly to manufacturing. About a little over 12% of Illinois GDP is attributable to manufacturing, making it the largest share. And yet significant challenges manufacturing is facing right now. I know we've discussed in the subcommittee over the last months the disconnect between many academic institutions and industry. It often makes it more difficult to train our next generation's workforce. There's also obvious tax and regulatory issues U.S. industries face. I know I've heard excluding labor costs, it's still 20% more expensive to manufacture in the United States compared to other trading partners. So my question first would address to all of you, if you could make a comment. I know the goal of the proposed network is to aid high-tech manufacturing in the U.S., and I absolutely agree that we need to encourage this. Some might say, though, if any amount of federal spending on science and technology, they question whether that would help manufacturing as much as significant regulatory and tax reform potentially would help manufacturing. I wonder if you could provide us with your thoughts on this, as well as how to create the optimal environment to support high-tech manufacturing and job creation here in the U.S. I'll throw it out to any of you if you have thoughts. I know it's a big question.
That is a big question, Congressman. Thank you for that. A month ago or so, Speaker Boehner visited one of our member company facilities in Ohio, not in Silicon Valley. It was a subsidiary of a Silicon Valley company that made very highly specialized components, which sort of speaks to the complex nature of supply chains. And it was very interesting when Speaker Boehner asked about how he sees priorities, mentioned that the application of research and development, that he understood that, particularly from some of the enterprises in his district. And I think that is an essential point from an industry perspective, is being able to harness the synergies of research and development, get over the valley of death, and commercialize. And that can happen in synergistic ways in centers such as the ones defined by this legislation.
Any other thoughts? Again, just boiling the question down. I mean, I absolutely agree. I want, basic talk all the time of encouraging research and development, and want to make sure we've got that commitment. But I also, what I hear from my manufacturers is they want to do that, but biggest weight they feel is regulatory burden and tax burden. So sorry for the feedback. hopefully we'll get that taken care of. But any thoughts on that? Again, we'd like both, but to me, what I'm hearing is a prioritization on regulatory reform and tax reform. Would you agree, disagree?
We would certainly agree that regulation reforms would greatly help in any state, Illinois, Michigan, New York. I think any state that would certainly be beneficial. But I also want to point out, you made the point between research and development. So we're the best country in the world in research. I don't think anybody would doubt that. We are not the best country in development. And so we are researching for the world and giving it away in TRL 4 to 7. And, from an investment perspective, we really need to go longer and maybe more focused. And thereby we would reap for the nation the benefits of the research we are doing in 1 to 3. I'm not for cutting research. I'm just for, let's think about how we prioritize that in a way that we're not doing research only, we also move it through that valley of death and get to the development.
Yeah, I think we all want that. Another thing I talk about all the time on the committee is when times are tough, and certainly they are right now, what can only federal government do? And that's where I think basic scientific research is something that is very difficult to put together a business plan that makes sense for basic scientific research. It's still tough for development, but it's a little easier if you have kind of the understanding of why something works to apply it and make our lives better for it. So I'd love to do both. I'd love to have the resources we need for both, but I think that's the challenge, is making sure we still are strong on the research side while also pushing, as opportunity comes and resources come, to find ways to work with industry to continue development. So totally agree. My time is winding down. Real quick question, may I, Chairman? Mr. Davis, just quickly, you touched on some of the foreign government subsidies for your industry that lure away American companies. Wonder if you can expound on what these incentives are, but more importantly, what impact they might have on the U.S. economy, and if there's any national security implications of these supply chains moving overseas.
Well, speaking primarily for the commercial aspect, I think what we see increasingly in foreign governments is a choice to compete and a decision to move from making stuff to designing stuff, to move up the value chain. China's 5-year plan is very specific in identifying and unambiguous in identifying key technology areas to make substantial investment. So I think some of the ways in which foreign governments appear to provide great clarity is being specific about the kinds of industries that they want to develop and cultivate. Certainly as industry migrates overseas and the research and development and the capacity to manufacture moves with it, there are certainly national security implications.
Again, my time has expired. Thank you, Chairman. If you wouldn't mind, if we could follow up with the questions we might have just to get a little bit more detail. I know our time is limited here today, but thank you so much. I appreciate you being here and all the information you've shared. Thank you, Chairman, for your generosity.
Again, now recognize Ms. Kelly for her questioning.
Thank you, Mr. Chair, and thank you for being here today. I am also from Illinois and represent the south side of Chicago and further south, and manufacturing is one of my biggest employers, but we're suffering in my area from unemployment higher than even the state of Illinois' average. You talk about in your testimony, Dr. Biller, the importance of small and medium-sized manufacturers, and indicate that the Centers for Manufacturing Innovation proposed by the legislation can help small and medium enterprises introduce novel manufacturing technology into the U.S. supply chain more rapidly. What do you think are some of the specific challenges faced by some of the smaller manufacturers?
Well, let's try and take the idea of creating a new product and the new product lines in the virtual space, because that's really where the development is going, that people are creating something in a computer-aided design, then they move it to computer-aided manufacturing, computer-aided engineering. Everything happens essentially in the computer. It's all digital. And so now our suppliers, especially the smaller ones, might lack A, access to such tools because they're expensive, and B, access to engineers who can operate those tools even if they had those tools. So for us, it's really critical that those SMEs get trained in these skills, and that they have access maybe on a buy by the drink way through an institute way, so that they can actually continue to be our suppliers or become our supplier. What we want as General Electric, we want to have as competitive as a supply base as possible. It helps us, it helps the nations, it helps the suppliers, it helps everybody. And so we think that is really critical, that we get to such an environment where people have access to that. And if we don't allow SMEs to acquire such skills, then we'll see what we have seen before, that companies will leave because they have such skills in other countries. And let's make no mistake about it. China, Germany, Japan, they are all helping their SMEs to get such suppliers. Fraunhofers have been in existence for 60 or 70 years, continuously, basically serving as a transfer mechanism from one SME to the next by developing the technologies in these federal institutes. So we think this is really required to continue to have an SME base, and maybe even to expand the SME base, and hopefully help your district to get to a better employment level.
Right, because it's more the small and medium-sized manufacturers that really hire the area residents, and that, like has been said already, that people have great concern about not being able to replace people when they retire because people don't have the skills.
Yes.
Thank you.
Thank you. I now ask unanimous consent for Mr. Kennedy to participate. Without objection, the chair now recognizes Mr. Kennedy for 5 minutes.
Mr. Chairman, thank you. I appreciate that. I appreciate the time today and your patience and generosity to add me on. I also want to thank you for holding this hearing, and for a big round of thanks to the ranking member as well, Mr. Lipinski, for all of his support, not just for the bill, but for advanced manufacturing and the concept behind this bill for quite some time, sir. So thank you very, very much. Mr. Collins, thank you for your questions, for making the time, and for your support of the legislation as well. And I saw Mr. Reed pop in. I know he's going to be here back momentarily. To the witnesses, thank you very, very much for your time. Thank you for your testimony. I have, Mr. Chairman, with me a number of letters of support from some outside organizations that I wanted to submit for the record, if I could. So I ask with unanimous consent.
Without objection.
To the record. Thank you very much. And they are from the Motor and Equipment Manufacturers Association, the National Association of Manufacturers, the Information Technology and Innovation Foundation, which includes Alcoa, ANSYS, Applied Materials, Autodesk, DuPont, National Modeling and Simulation Coalition, Owens, Illinois, Rockwell Automation, TechSolve, Cal Berkeley, Cal Irvine, University of Southern California, One Voice, representing the National Tooling and Machining Association and the Precision Metal Forming Association, Precision Machined Products Association, Dow, and the Semiconductor Equipment Materials International, otherwise known as SEMI. Mr. Davis, thank you very, very much. I wanted to speak briefly. You'll be hearing from me in another couple minutes, so I'll try to keep it brief. A number of comments from, I think, the witnesses and from my colleagues here, I think, took the holistic view of the challenges facing the U.S. manufacturing industry, from regulation, taxes, uncertainty, overall economic uncertainty here in the United States and globally, the training issue that has come up time and again, sir, as well as energy costs and the potential innovation surrounding energy costs that could lead to at least a support for bringing some of this manufacturing processes back home. I wholeheartedly agree with all of those observations and critiques. This bill obviously attempts to try to get at a small part of this, but I think a critical part nonetheless. And Mr. Biller, I was hoping to get you to elaborate a little bit, seeing as GE is involved in one of these pilot programs in Youngstown, Ohio, that you already mentioned already, the Ohio National Additive Manufacturing Innovation Institute, focused on additive manufacturing, otherwise known as, or perhaps more colloquially, 3D printing. And I just was hoping that you could discuss a little bit more about how big companies like GE can work effectively with smaller and medium-sized enterprises to fill that gap that you, I think, so eloquently described, that valley of death that exists for so many companies out there. If you could just give us a little bit of an overview from your experience.
Sure. So GE has been a founding member of the NAMI, the National Institute for Additive Manufacturing in Youngstown, Ohio. The great thing about this institute is I think we have close to 100 companies participating in this program. And so this allows us to work closely with the suppliers. We can understand better what their capability is. We can help them understand what capability we are looking for when we're looking for a supplier. It allows us to grow our own capability. Additive manufacturing for production is a fairly new field, so it will allow us to have access to people who are being trained in additive manufacturing, as well as our suppliers who have access to people who are coming out of school or who have been employees at that center. And typically the employees at these centers, they cycle through the center, they stay for 2 years, and then they move on to go work in industry typically or in academia. And so creating that kind of environment where people can get together and say, here, this is as a nation where we want to go in terms of additive manufacturing. We all agree that this is pre-competitive, and here's where we can move the needle from it being very new technology and unestablished technology where we don't understand material properties, where we don't understand how to produce this at a lower cost and so forth, to a level where it becomes competitive and where we get a supply base and, in fact, establish a supply base in additive manufacturing. It's a very new field, and so I think this was really an ideal first CMI.
Thank you, sir. And Mr. Davis, if I could, and I realize time is brief, but you mentioned a little bit before some of the unique challenges, I think, in your comments about the speaker, about that comes to grips with as you're trying to develop new products without being burdened by high costs and the high risk associated with that type of innovation and the costs associated with it. Can you discuss a little bit on how the semiconductor industry is impacted by these issues and some of the ways that hopefully a model like this will address it, even though I'm 10 seconds over time?
Thank you for your leadership on this bill, Congressman, and thank you for the question. I think the essential thing facing manufacturers such as those in our association is how you maintain a pace of innovation. And innovation isn't something you fund once, buy, and then you've got it. It is an ongoing process that needs to be sustained within this country. By way of example, when I think about innovative products, things that have changed our economy and our competitiveness, you look at this thing, which I believe probably every person in this room has one of in their pockets. Every single element of this smartphone that makes it smart is a product of industry collaboration and public-private partnerships. Touchscreen displays, global positioning system, the internet, wireless connectivity, microchips, all those things were products of public-private partnership. So the vision and leadership that this country can take through acts such as this lay a foundation for future prosperity in this country and innovation. And I'm not sure if that answered your question specifically, but
beautifully, sir. Thank you, Mr. Chairman. Thank you for your generosity. I'm sorry to cut it short. Thank you very much.
You're welcome. At this point, I'd like to thank the witnesses for their interesting and valuable testimony. The witnesses are excused, and we'll take a short break while we set up our second panel. Thank you, gentlemen, for your testimony. Appreciate it. All right, we'll reconvene for our second panel of very distinguished witnesses.
Thank you, Mr. Chairman.
Our first witness is the Honorable Tom Reed, the representative from the 23rd District of New York and a member of the Ways and Means Committee. And our second witness is the Honorable Joseph P. Kennedy III, representative from Massachusetts' 4th Congressional District and a member of the Science Committee. As you know, witnesses' testimony is limited to 5 minutes, and I'll recognize Mr. Reed for his testimony.
Well, thank you very much, Mr. Chairman and Ranking Member Lipinski and members of the committee for the opportunity to weigh in and testify on this important legislation before you. And I do not anticipate taking the entire 5 minutes as I have submitted written testimony to the committee. And again, I sincerely would like to thank you for bringing this legislation before the committee today. I am proud to have introduced this legislation, the Revitalize American Manufacturing Innovation Act, with my good friend and good colleague, Congressman Joe Kennedy from Massachusetts, a member of this committee, as well as working in a bicameral fashion with Senator Jared Brown of Ohio and Roy Blunt of Missouri on companion legislation in the Senate. I think this is an exciting piece of legislation that is going to advance manufacturing in America. As a co-chair of the U.S. Manufacturing Caucus here in Congress, I am a firm believer that this legislation will take a step in the right direction to enhancing American manufacturing and partnering and bringing manufacturers together with academia, businesses, institutions across America in a public-private manner to bring products from the lab into a commercialized setting and to address the clear workforce development issues that we face in America in regards to matching up the skill sets of advanced manufacturing in particular, as well as all U.S. manufacturing. And this bill, in my opinion, brings that public-private partnership mentality together for purposes of innovation, workforce development, and a firm commitment to a philosophy that I believe in, and that we're going to make it here to sell it there. You know, as I serve on the Ways and Means Committee and do a lot of work on the trade front, one statistic really jumps out to me on this issue, and that is people need to realize that on the world economic stage, 95% of the world's consumers live outside of U.S. borders. That means we have to build it here, sell it there, and having this type of legislation, in my opinion, will bring together those public-private partnerships that will encourage and empower U.S. manufacturing to be competitive and to really achieve that goal of making it here to sell it there. You know, I come from a district of Western New York, as the chairman knows. It's an exciting area of the world in the sense that we are headquartered in my hometown of Corning, New York, Corning Incorporated, the makers of the glass that many of us have in our products that we have with our iPads and our iPhones, and companies like Dresser-Rand, Cummins, and Lufkin. They are all posed to gain from this legislation and the concepts that we have here put forth. I was proud to work with a constituent company of G.W. Lisk and the Finger Lakes Community College to partner those two institutions up on a pilot demonstration project where the community college was using the resources of that manufacturer, and that manufacturer was using the resources of the community college to create a work training program that brought kids, younger men and women, from a situation where they didn't have the skills to participate in that U.S. manufacturing setting, and at the end of that program were certified and moved right into an employment situation. That's what this legislation is trying to do in part on a national level, and we're proud to be partnering with that. And so with that, I just ask the committee to weigh favorably in on this legislation, and I appreciate the effort that you have done in highlighting RAMI and the exciting opportunity that it represents, and working with a true good friend, with Joe Kennedy, on this legislation. It has been a joy, and it's been something that I think we can be proud of in a bipartisan, bicameral manner to advance U.S. manufacturing here in Congress. And with that, I yield back.
Thank you. Now recognize Mr. Kennedy.
Thank you, Mr. Chairman. Thank you again to Ranking Member Lipinski, to members of the committee that are here. Thank you for the invitation to come and testify about the Revitalize American Manufacturing and Innovation Act, otherwise known as RAMI, H.R. 2996, a bill that we've been working on very hard with my colleague, Mr. Reed from New York. And I also want to thank, as I said a moment ago, the Ranking Member, Mr. Lipinski, for his leadership on this issue for a long time, for his co-sponsorship, as well as the Ranking Member of the full committee, Ms. Johnson, and Mr. Collins as well, for his co-sponsorship. I also wanted to recognize Senators Sherrod Brown and Roy Blunt for their introduction of companion legislation in the Senate. Back home in the Commonwealth, machines are buzzing today. At Thermo Fisher Scientific in Franklin, they're lacing together complex engineering processes to build air quality monitors that help keep our air clean around the country. At Johnson & Johnson and Raynham, 3D manufacturing models are becoming wax structures that ultimately give doctors the ability to conduct intricate spinal surgeries and create custom titanium joints for knee and hip replacements, among many others. At General Dynamics in Taunton, cutting-edge technologies are being utilized to create life-saving battlefield communication systems for our men and women in uniform. From the Berkshires to the Blackstone Valley, Massachusetts manufacturers are innovating at a breakthrough pace, breathtaking pace, and are carefully rebuilding what our sluggish economy needs most: stronger, more sustainable pathways to middle-class jobs. In doing so, they're promoting a model of economic development that is locally sourced and regionally driven. The Massachusetts story is not unique. Across the country, innovation industries are transforming the American economy and giving our once fading manufacturing industry new legs of innovation, like advanced manufacturing, life sciences, information technology, and defense. For the past 6 months, manufacturing activity has steadily expanded. In November, it hit its fastest pace in 2.5 years, and that growth is expected to continue. U.S. high-tech manufacturing is the largest in the world, accounting for $390 billion of global value added in high-tech manufacturing in 2010. However, the share of U.S. manufacturing in the U.S. share in the world market has declined from 34% in 1998 to 28% in 2010. And in 2011, the trade deficit advanced products was equal to 17% of total U.S. trade deficit. There's no doubt that manufacturing has suffered mightily in the past few decades. But the slow and steady improvement that we see today is positive. In a time of growing income inequality, and a time of still evaporating middle-class jobs and decreased economic mobility, manufacturing can and must remain the cornerstone of the American economy. As policymakers, we want the success that we've seen in recent months to continue. Then we must focus our efforts on better linking innovation and manufacturing sectors, understanding that the latter is critical as a vehicle for bringing the former to market. I am proud to be here to testify in support of this bill, which Congressman Reed and I believe will help accomplish these important goals. The Revitalize American Manufacturing and Innovation Act focuses on building, as MIT puts it, industrial ecosystems that bring together businesses, educators, innovators under one roof to pursue manufacturing processes that are relevant to the local economy. Currently, very few of these coordinated regional support systems exist for manufacturers, innovators, and entrepreneurs outside of places like Cambridge, Silicon Valley, parts of New York and Ohio, leaving independent businesses to fend for themselves. Rami aims to fix that, and as Congressman Reed pointed out in his testimony. This bill uses some public funds to fuel the creation of these regional institutes, mandating that any partnership be wholly self-sufficient within 7 years. Most importantly, Rami sets a strong framework and then lets local stakeholders take the reins. This is locally driven, public-private partnership that should be a model that has fueled so much success back home in Massachusetts, where Governor Deval Patrick has created regional networks around science, technology, engineering, and mathematics, otherwise known as STEM education, and advanced a statewide manufacturing collaborative. These efforts have allowed Massachusetts to focus on the specific needs and strengths of different parts of our state and avoid a top-down, one-size-fits-all approach to economic development and job creation. As a result, precision manufacturing and advanced manufacturing businesses are steadily growing, bringing with them solid middle-class jobs that hold enormous promise for industrial communities that have long been the backbone of our economy. Advanced manufacturing jobs in Massachusetts have an average annual salary of $75,000, and economists forecast over 100,000 jobs in this sector opening up over the next decade as older workers retire, not to mention the brand new ones that will come from any additional economic growth. Mr. Chairman, thank you very much for the opportunity to testify today. Thank you to the committee for the consideration of this important piece of legislation, and I ask for all of you to look on it favorably as well. Thanks very much.
Thank you very much, gentlemen, for your testimony. We heard today on the first panel a lot of great ideas that going along with your bill. And as a member of the Education and Workforce Committee, from that angle also about the future of American manufacturing and about workforce development and how that really is going to needs to start in K through 12 education and increase our pipeline, so to speak, development into highly technically trained people that are filling the 21st century jobs. As both of you know, when you go into our factories today, the high-tech computer work is needed. Almost everything is robotic, even in small manufacturing facilities. And if we're going to continue to be competitive internationally, workforce development is very important, as well as also, I think some of the larger issues that we also discussed related to regulation, taxation, and everything else that we can do. But I have a lot of confidence in America to compete. We always have, and we always will. And this is a critical area that we need to work on. So thank you again. With that, the record will remain open for 2 weeks for additional comments and written questions. And the witnesses are excused and the hearing is adjourned. Thank you very much.
Thank you, Mr. Chair.